6.1, we are talking about rationals, and we're going to multiply and divide them. And so to start out with, they give you an example of a rational function like this. So a rational function is one where you have a fraction with x's or variables in both the numerator and or the denominator. Example of a rational function. So x's, fraction, and what they want you to do first is find the domain. So what I want to figure out is what x values will give me a solution, an answer that I could graph on an xy plane. So if I'm going to find the domain of this, you can imagine putting in, for example, 1. And I would get 1 squared plus 1 is 2. And 1 subtract 6 is negative 5. 2, 3, 4. All those numbers you can plug in and you'll just fine. But there's one number that causes a problem. And that is the number that would make it undefined. And you might remember that it's undefined if you're dividing by 0. So if I were to have 8 divided by 0, I would plug that in my calculator and it would say error. It can't do it. So what we need to do is figure out when this is undefined. So we just simply take our denominator and set it equal to 0 and solve. So I'll add 6 to both sides. So if x equals 6, you can see that you would have 36 plus 1, you'd have 37 divided by 0. And 37 divided by 0 is, your calculator can't do it. So what we need to tell them is that every x value works except x cannot equal 6. So the way that MyMathLab writes that is kind of funky. They'll do a squiggly bracket and say x, remember this is shorthand for is such that. X is such that, and then they'll say x is all real numbers. Except x cannot equal 6, close parenthesis. And so all you're figuring out is this right here, and this will be the same every time. So let's try this one. Let's say I give you 5x plus 4 divided by x squared minus 3x minus 10. Well, once again, we need to figure out what x value we would plug in right there that would cause it to equal 0. So we can do that by setting that denominator equal to 0. And guess what that means we're doing? Factoring. Just like you just learned in all of chapter 5. And I told you factoring will never go away. Everything you do now will include factoring. So, you know, the only thing that can be x squared is x times x. That's easy. And then I could have 10 and 1 or 2 and 5. And you might see that 2 and 5 will add up to 3. Actually, their difference will be 3, won't it? Because I know one sign has to be positive and one sign has to be negative. And I know the biggest one has to be negative for my middle to be negative. So I have negative 5x and positive 2. And you'll remember, inside times the inside is negative 5x. Outside times the outside is positive 2x. So if I combine those, I will get my middle term, negative 3x. So we know we've factored it correctly. Now I just take each factor and set it equal to 0 and solve. And so we get x equals 5 and x equals negative 2. Now remember, that's not our answer. That's what will not be part of the domain. So once again, we want to say x is such that x will negative 2 or 5. And I just wrote those smallest to biggest. Of course, order doesn't really matter, but that's how your answer is going to look. Now, what if I gave you something like this? What if I said find the domain of this number? Well, now, if I set my denominator equal to 0, there's no variable to solve for. So there is no solution. 4 does not equal 0. And if there's no solution, that tells me that my domain is all real numbers, because everything will make it undefined. Alright, now the thing that's actual math is they have you simplify. So, let's practice simplifying. What if I saw something like this? Now, the rule is you can only simplify if you can take it out of every single term. So right here, remember that terms are separated by plus or minus signs, not in parentheses. So I have 1, 2, 3 terms. What can you take out of all three? Well, you probably see you can take a 3 out of all of them, and you can take a y to the third out of all of them. And when I say take out, we know that means divide. So this first one, I'll show you that step. We're going to divide every single term by 3y squared, or 3y cubed, I'm sorry. So I have this. If I take that out or reduce it or divide by it, so on the top I have 1, right? This divided by itself is 1. Here I have 2 and y, and here I have 1. And don't forget, if you take the whole, you put a 1 in its spot. So that is simplified now. That is simplified. Those are equivalent. How about this one? Over 3x squared plus 4x minus 7. Now, you have 1, 2 terms. And guess what? There is nothing you can take out of all 6 terms. So when that's the case, that's where we resort to our factoring. So I'm going to go ahead and factor the top and factor the bottom. And once again, feel free to factor by grouping, factor however you factor best. I know that the only thing that will be 5x is 5x times x, and I know the only thing that will be 1 is 1 and 1. But what I have to be careful about is my sign. I know that 1 is positive, negative 6x, you know what? That must be supposed to be a plus. I think I couldn't read my notes very good because it won't factor if that's not a plus. So make that a plus. Now I know the signs have to be the same. And for those to be the same and add up to negative 6, they'll both be negative. So a negative times a negative gives me positive 1. And then I have negative 5x on my outside, negative 1x. Now the only thing that can be 3x squared is 3x times x. And I know the only thing that can be 7 is 7 and 1, but we just have to make sure we put them in the right places. This is negative, so this one it will be positive and negative, or negative and positive. My signs will be opposite, and the biggest has to be positive. So I think, and you might need some trial and error to get it, but you know the 7 goes here and the 1 goes here, because that will give me 7x and 3x. And I want my 7x to be the positive one, and my 3x to be the negative one. Alright, now after you factor, however you factor, trial and error, factor by grouping, you should end up with this one term, because it's something times something, and they're in parentheses. The minus sign is in the parentheses. So this is one term on the top, and this is one term on the bottom, and they both have x minus 1 in common. So I can cancel that. And my answer is what is left right there. Okay. Now, they can go one step further, and they can ask, well, you know, let's do one more of those. Let's do this one. They're going to have all kinds of factoring. So I saw this and thought it would be a good review. Again, your directions are just simplify. So we're simplifying this. That's x to the third. And as soon as I see a third, I know that it's a cube. And 3 times 3. So this is a sum of 2 perfect cubes. And so I know, I have it memorized. I know, and you better have it memorized, a binomial times a trinomial. I know the signs are same, opposite, always positive. So, remember that acronym? I know I take the cube root of x to the third, which is x. I know I take the cube root of 27, which is 3. Then, whatever you put here, you square right here. Whatever you put here, you square right here. And you multiply those for this term. And nothing in the bottom can factor, so I'll just rewrite that x plus 3 term on the bottom. That whole thing will cancel. And I guess we would want parentheses so we know that that's one term. But that means that's your answer. That's what you're left with. Alright, now they'll go one more step and they'll ask you to multiply. And then you'll see something like this. So maybe pause it for a second and write that down. And you try and factor it to begin with. And then see if you factor correctly. So I can see that I have a common factor right here. So I'm going to pull that 5 out, which gives me x plus 1. And I have a trinomial here, so I will factor it into two binomials. And the only thing that will be 2x squared is 2x times x. And the only thing that will be 3 is 3 and 1. Just make sure you put them in the right places. So you have 3x and 2x. And you want the biggest one to be the negative and the smaller one to be positive, because one has to be plus and one has to be minus to get negative 3. And then you can see that this whole entire binomial cancels. And this whole entire binomial reduces. And then there's even one more thing to reduce. 5 divided by 5 is 1. So my answer is, now be careful, that x is on the bottom and it stays on the bottom. And on the top, everything is reduced, so you have 1. Alright, now the other thing they can do to make it a tiny bit harder is they can have you divide. So let's say I give you this one. Let's divide 8x plus 3, and that whole thing will be over 20x squared plus x minus 1. And we're going to divide this by, and these are big, 2x squared plus 7x plus 6 all over 35x squared plus 3x minus 2. Now I'm going to take that to the top of my paper right up here. So I'm going to write this up here, because the very first step, the first thing I want to do is change that divide to multiply by the reciprocal. 5/7 divided by 2/3. We know that that's the same as 5/7 times 3/2. And then you just multiply top times the top, bottom times the bottom. So we do the same thing with rational expressions. I just rewrite the first one without changing anything, and then I change it to multiply, and I'm going to put the denominator on top and the numerator on the bottom. So, and make sure you copied it right, didn't mess up any signs. Now we know right now we have 3 terms, and so nothing reduces. Nothing you can take out of all, how many ever, what is that, 12 terms? So let's begin by factoring. And in this first one, I know the only thing that can be 3 is 3 and 1, so I'll start with that. And I even know that my signs will both be positive, because it's positive 3 and positive 14. Now I have to think, what times what is 8? And when I put the outside times the outside, and it's going to look like 4x will be here, so I get 12x, and 2x will be here, so I get 12x plus 2x. There's my 14. Make sure you do that on your own and then check it. Stop and do it by trial and error, or do it by grouping, so you get good at factoring. Because like I say, factoring will not go away. Just do it until it comes to you fast. Here, I know the only thing that can be 1, and I know that one sign is positive and one sign is negative. So I know that I'm taking a difference, 4x and 5x. And I can see that the 5x, the inside times the inside, needs to be positive, so I get positive x. And the 4x, outside times the outside, needs to be the negative one. Alright, factoring this. I'm telling you, you're going to be good at factoring. Just keep doing it till you're good at it. And the only thing that can be 2 is 2 and 1. Again, I know that my signs are different. One's positive and one's negative. And that the bigger one has to be positive. That'll work. Look, I can put 5 here and 7 here. And then I get 10x. Outside times the outside is 10x. Inside times the inside is 7x. And I need my 10x to be positive and my 7x to be negative, so that they will add up all over On my bottom, this time I know the only thing that can be 2x squared is 2x times x, and they have to add up to 7 and multiply to be 6. I know both my signs are positive because both of those are positive, and so I can see that I'm going to put a 2 here, so I get 4, and a 3 here, so I get 3, so 3x plus 4x is my 7x. Alright, now that you've completely factored it, now you only have one term on the top because there is no plus or minus sign, not in parentheses. I have one term on the top and one on the bottom. So anything that's the same, you can reduce. And so that's what I'm doing. And look at all those similar binomials. So my don't you dare reduce those 2's or those x's, because now you have 4 terms. And unless it's in every single term, you can't reduce it. So this is a great chapter section that will review factoring with you, and you'll get really strong at factoring. So good luck with it.